Alright, so for the 12th day we are still trying to contact the elves, but it looks like we are too low to be able to get a decent signal on our device. So we get the height map of the surrounding area and we want to reach as high as possible in the fewest amount of steps. The problem is that there are some elevation differences which are higher than just one step, and to make the trip easier we want to be able to make steps of only one unit of height. So for example, if we annotate the heights with the letters from A to Z, it means that we want to be able to move only from A to B or to B from C and so on. And another trick I guess for this question is that you should also be able to go down any amount of steps. So for example, you can go from D to A, but the other way around you can't. And you also can go from A to A, like not going up or down, just moving horizontally. So yeah, I guess I quickly realized that this might be a problem that can be solved with Dijkstra, so that is a bad sign already. So yeah, for the first part we have to get the number of steps from the starting position, which will be given in the input as a capital S, and to reach the destination position, which will be given as a capital E. And in the example from the problem statement, it took 31 steps. So for the second part, we can actually start from any location on the map that has a height of A, like 0. So what we have to do is try to figure out which is the best starting location from all the lowest points. So we have to apply the search algorithm from each A position, and in the input, like, the best solution was 29 steps for their example, so lower than 31. Alright, so for the solution, I thought it might be easier if I use a hash map from the position of on the map to its height. So to read the map, I went over each line and over each character and converted it into its height, and I did that by subtracting the lowercase a letter from the character. And also, to figure out which is the starting position, I looked for the capital S and marked that XY pair as the source, and capital E to figure out if it's the destination point. So basically, to parse the input, I just used the implementation of from stir for the map structure. Then I implemented a neighbors function, which takes as input the map and the current node. And what it does is to go through all 4 directions, up, down, left and right, and it just checks if the new point is inside the map, and it also checks if its value is at most 1 above the next value. So basically you can go down any amount of steps, but you can go up only 1 step, and if that happens, then we return the point as a neighbor. Then I implemented the shortest path algorithm using Dijkstra, and yeah, it's pretty much just the Dijkstra algorithm copy pasted from Wikipedia. So the idea is that we have a distance hash map where we map each point to a cost, and pretty much this cost is the distance from the beginning up to this point. And then we also have a binary heap where we keep the current state, basically the cost and the position of the current point. Then we go through all the points in the heap. The first time it will be just the start point with a cost of 0, because you need 0 cost to get from the beginning to the beginning, I guess. If the position is equal to the goal, then we found the shortest path, so we just return the cost. Then we have to compare the cost of the current point with its lowest distance that we got so far, because the hash map keeps the smallest distance for the points. And I forgot to say, but initially we initialize it with the maximum value. So we compare the cost of the current point with its lowest cost, and if the cost is higher than the lowest cost, then we don't care about this path because it's clearly worse than the best path. So after that, if we find a cost that it's better than what we found so far, we go through all the neighbors of this position, and I considered the cost to be 1 because we want to have as few steps as possible. We don't really care how many up or down steps we take. We just want to have the shortest path in like amount of moves. If the cost to the next edge, to the neighbor edge, is lower in the current path, then it's a minimum path from the distance hash map. Then we push this new state into the heap and we update the minimum distance. So next time we check with this edge, we can see if we found a better path or a worse path. And yeah, ideally we'll find the goal at some point, but if we don't, we have to return a none. Then for the first part, we just want the shortest path, so we call the function. And for the second part, we want to apply the shortest path on all the starting points. So instead of only applying shortest path on the SRC of the map, we apply on all sources that have the value of 0 or have the height of a, of lowercase a, and we take the minimum of all these paths. Maybe something that you had to pay some attention to was that idea of being able to go down any number of steps, because I made a mistake at some point in solving the problem and I wasn't getting the correct result because of that. So after reading the statement a couple of times, I figured out that I have to be able to go down any amount of steps. So yeah, basically that was maybe a small thing that, like, maybe that was the trick of this day. I mean, I guess it was okay. Usually I like more problems that you have to come up with your own solution, and it's not really that you just copy paste an algorithm and it works first try. So yeah, but still cool. So yeah, if you want to check the code, you can find it on my GitHub, and see you guys next time. Bye bye.